Let's get your feet wet with Marine Solutions at the man-made pond created specifically for the off-site demo.
So this would be our kind of the most common solution you would see for dredging, at least the stuff that we do. So the Z-boat, that's the unmanned vessel over here running around with dual GNSS on it as well, has a sonar on it. You can actually just plan, just like a drone, you can plan a mission for that thing. It does its pattern, it's collecting the sonar scan of the bottom. That comes back and becomes the surface that we use to create our 3D visualization and know where we need to dredge to.
Next up, optical surveying.
We got a couple of our flagship products here, our scanning E612 total station. So I guess you can look at this as like the next evolution of optical surveying. Traditionally, you collect discrete point data, so that might be an XYZ coordinate on the ground. Now we're collecting that XYZ coordinate data, we're collecting images, we're collecting RGB, colorized data, we're collecting color intensity. So the richness of the data that you're able to get is just, it's magnified, it's accelerated, it's amazing.
We spent a few minutes indoors to see what a connected site would look like in an office setting.
So connected site's all about actually connected data, common workflows, and a process to actually help us deliver a project in a more efficient, more sustainable manner. So what we're looking at here is, okay, here's Trimble Connect. We're using that to collaborate data, which we might be getting from a number of consultants. We can then use a piece of software like Trimble Business Center to start looking at takeoff and estimation, and then tie that into workflows around the B2W portfolio that we've just introduced to Trimble recently. So that's sort of one big aspect of what we're doing as far as connected site from a data, common data, and a process perspective to how to deliver out to the field what's happening.
Back outside, a prototype AI system installed on an excavator can monitor operation and progress being made on a job site.
But what you have on that excavator is a computer vision system where we're plopped on a camera, an edge compute box of this size, and thrown in a couple of machine learning models to do two things. Primary thing being looking at every second of your excavator operation and saying, are you scooping, are you rotating, are you loading a truck? With a second model, we're detecting the presence of the trucks, whether it's 0 trucks, 1 truck, 2 trucks, 3 trucks, so forth. And the idea with this is to automatically generate this productivity information to complement our earthworks platform. So you get your volume from there, right? And you get your productivity events from here. So you're looking at, hey, truck showed up at 9 a.m., you loaded 20 trucks within the first 2 hours, operator went to take a bathroom break, and trucks stopped showing up, so no productivity events to be had. But really automated 5-minute install on Sunday, so we're very pleased that went very well. And we can basically take the system, drop it to the CAT excavator, and 5 minutes and that's it. So very, very exciting new technology for us. Early stages, functioning prototype, but we're really excited about it.
Another station emphasized the precision and efficiency of milling technology.
Technology helps with all aspects of this, planning and execution and own, operate, and maintain, because we get the right material in the right place at the right time, okay? So the mill, that's what we want to really focus on when we fix roadways and profile roadways. There's a great video back at the Venetian running of an airport in Luxembourg that could only operate from 10 p.m. to 6 a.m. They had a whole lot of work to do. They actually put 6 3D mills side by side, all overlapping just barely, ran them all the way down in 3D, followed right behind with 6 asphalt pavers running in, it's called echelon, running an echelon, filled that up with the asphalt so that come 6 a.m. they can start using the runway again. The next night they stop where they left off the day before, 6 mills, 6 pavers, the job gets done, precise, quality, and predictability, which we really like to see.
For me, the most eye-opening demonstration was 3 unmanned machines working together at the same time.
So when this machine shows up, it picks the spot, it works backwards, and it's going to fall in alignment and dig that trench with no operator, no assistance from anybody besides the software on that machine. Right, so it's running fully autonomous. This dozer right here is actually remote controlled up there in that tent. So that's another technology we're highlighting here just to show a window into the future of what a construction site can actually look like in the future. And then the last piece over there is going to be a compactor. It's actually running fully autonomous as well. Now it actually has what we call like a mission plan. It's got a path plan. So
what they've done is they've selected a boundary, gave it a task of, hey, we need to complete this compaction with this amount of ratio or this amount of pass count. They give that task to the machine. It will run an optimum path for that pass count compaction, complete the task, and then it will park the machine, right? The other cool piece they're showing here is that these all three can work together, right? And a lot of that has to happen with the data. Now, there's a lot of data behind this. There's a lot of information being sent back and forth. How was the task completed? How much work was done? And all this is sent back and forth to the office and back to the field.
In northern Las Vegas, Nevada, Arturo Santiago, Heavy Equipment Guide.